Two astonishing findings with the James Webb Space Telescope focusing on the study of extrasolar planets or planets that orbit around stars that are far away were published in July 2024. The first is about the boundary region between the day and night in WASP 39b, a well-studied planet that is relatively close and has an inflated puffy atmosphere letting through a strong signal from the starlight filtered to the gas and providing the perfect scenario to do transmission spectroscopy to determine its composition. Because of these properties, WASP 39b became the first exoplanet observed by JWST, and using transmission spectroscopy confirmed the presence and amount of CO2 in the atmosphere of this giant. However, previous studies revealed that the planet is tidally locked to its star, much like Moon is to Earth, heating the gas in the permanent day side to much larger temperatures than the night side, and probably leading to large instabilities in the atmosphere. Given that transmission spectroscopy assumes there is a uniform atmosphere, astronomers started to question the accuracy of the results obtained by previous observations. So a group of astronomers led by Dr. Nestor Espinosa decided to check this using the early observations, but this time focusing on the gas around the distinct and fixed boundary between the day side and night side known as the terminator. Using 3D general circulation models similar to those used to predict weather patterns on Earth, the team determined with considerable precision the temperature on both sides of the terminator. The evening border is 1,450 degrees Fahrenheit and is hotter than the morning edge that is only 1,150 degrees Fahrenheit. The temperatures actually can be explained by the movement of the gas from one side to the other via a powerful equatorial jet stream. The air pressure difference in the hot day and cold night produce winds that reach thousands of miles an hour, circulating the air around the planet and slamming the day limb with air that has been cooled on the night side and hitting the evening limb with air heated on the day side. Although these observations indicate that the terminator has a dynamic atmosphere, the derived composition and metallicity still agree with the radius found previously via the transmission models, a result that is reassuring to astronomers. The second study tells us about the direct observations of one of the coldest exoplanets observed to date, Epsilon Indi Ab. The planet was discovered by measuring the movement of its parent star, Epsilon Indi A, a K-type star similar in age to our Sun but slightly cooler. Astronomers observed that it had a wobble that could be explained by the giant planet orbiting the star and disrupting its movement. In 2018, a group of astronomers determined that the planet should be a gas giant about 3 times the mass of Jupiter, with a nearly circular orbit and an orbital period of about 53 years. Because a planet like this emits most of its light in the infrared, a group of astronomers proposed to use JWST to obtain a direct image and confirm previous findings. So using the coronagraph on the mid-infrared instrument, or MIRI, the team confirmed the existence of a planet several times the mass of Jupiter and with an estimated temperature of 35 degrees Fahrenheit, making it one of the coldest exoplanets to be directly detected. However, there is still unanswered questions as the observations indicate that this planet does not have all the predicted properties, so more observations are needed to confirm its composition and answer other questions astronomers still have about this system. If you like the information in this channel, please don't forget to subscribe.